how to say this? Many of the early mistakes that I made 10 years ago are still there in the source code, and they're hard to repair because, as I alluded to earlier, backward compatibility is a great, fantastic thing to have. Yep. But if you want to fix fundamental problems, then often it means you have to throw out the backward compatibility.
Machines are so fast and stores are so big that they give us plenty of latitude to screw things up.
The shell, which is the name we give to the command interpreter.
So the operator got a pair of tweezers and very carefully fished the moth out of the relay.
Because you've all read the mythical Man Month.
And the best motivator in the world for programming is scratching your own itch.
Developers.
Hello and welcome to another edition of the Sourcegraph Podcast. My name is Beyang, and on this show we talk with the people behind amazing dev tools and developer experience. Open source authors, maintainers, DevX engineers inside forward-thinking companies, developer advocates and educators, founders of dev tool companies, anyone and everyone who brings joy and delight into our lives as programmers. We talk about their work, we talk about their lives, we talk about their vision of what lies ahead for the world of code. Stay tuned. All right, welcome back, everyone, to another edition of the Sourcegraph Podcast. Today, I'm here with Han-Wen Nienhuys, the creator of the open source code search engine Zoekt, based on Google's original internal code search engine. He has worked on developer productivity and dev tools at Google for, I think, nearly 15 years now, where he has worked on or adjacent to many of Google's famed internal dev tools like Piper, its large-scale version control system, Bazel or Blaze, its large-scale distributed build system, and the open source code review tool Garrett, which is based on Mondrian, which was Google's first internal code review tool. So Han-Wen,
Garrett is actually the third internal code review tool.
Okay,
yeah,
got it. So Google way ahead of the curve on code review. But yeah, Han-Wen, thanks so much for being with us today.
No worries. Excited to be here.
Awesome. So, before we get into all the cool developer tools that you've built over the course of your career, I always like to kick things off by asking people, how did they get into programming and computers in the first place? So, what was your beginner story?
It actually starts with my parents. So my parents met each other when they were doing a PhD in mathematics, and so they're both mathematicians. And so when I was very small, we had our first computer, an Apple II, and my mom started. So my dad was teaching at university, and my mom first at a local high school, but then she also started teaching at university. And as part of that, she had this had to do courses on computer science. And so when I was small, we had these. So we had a computer around, and we had these books lying around. And when I was in high school, also my mom was like, you should learn Unix because it's really cool. Because you can learn how to write a compiler, and that's really cool.
Awesome.
And my dad had bought this book on the C programming language, which was, he never got around to studying it, but I opened it and I started working from it. And I thought it was really, really interesting. And I actually decided to study mathematics because my dad would correct exams, and he would always complain about the computer science students who weren't all that good at mathematics, and
not super rigorous.
And so I had this idea that computer science is for the not so talented students, and so I had better do mathematics. And so I studied mathematics, but during my studies, I discovered, so first of all, computers are fun, but also to be a mathematician, you really need to have a lot of intellectual discipline. So if you write a computer program with a bug, then the computer program will crash. And if you do mathematics, it's all on paper. And if you forget to carry a minus sign, then the paper doesn't crash. The paper just continues, and so you have to be really rigorous in checking whatever you're doing.
Yeah.
And it turns out that I have kind of a lazy streak, and so it seemed better for me to not make this into a career. And so I decided to do a PhD in computer science. So I moved cities. And at the same time, so I play music, and I had a friend, and together we built this software for typesetting music. So it's kind of like LaTeX, but for music.
Yeah.
It's still, the software still exists today. It's called Lilypond.
Awesome.
And it's, I'm actually, it's probably of all the things I did in my life, it's the thing that I'm most proud of, because it's, it's been around for 20 years, and it's widely recognized to be sort of the standard of fine typesetting.
That's awesome. I used a typesetting software a while back on Linux. I forget what it was called. Maybe it was Lilypond. But I remember it being like super fun and easy to. I'm not a serious musician at all, but just kind of messing around.
Well, you would probably know, because if it had a graphical user interface, it was not Lilypond, because Lilypond is it's a command line compiler.
Oh, interesting.
Right? You type code, and then you run this program, and then you get a PDF file.
Oh, that's awesome. Now I'm even more intrigued. Because I feel like the graphical, a lot of times GUIs can get in the way, especially when you're trying to write stuff.
Yeah. So we were, me and my friend were quite. We both had long hair. We were trying to not wear shoes, and we were very, into free software. And so we were also against graphical user interfaces. So I've become more mellow over the years. So our philosophy was that it's better to have a text-based system.
Awesome. So you worked on Lilypond, this musical typesetting piece of software, and then how did you go from working on that in open source and in the free software world to joining Google?
So I had my first job. I wasn't very happy with it, so I quit. I tried making money selling my knowledge of music typesetting to users. I discovered that selling things to musicians is not a very good business plan. I think I made like 6,000 euros in 1.5 years. And so I was sort of 1 year into this, and I got a call from a recruiter from Google. He said, do you want to interview for us? And so I did the phone screen. They rejected me on my second phone screen, but I was talking to these guys on the telephone, and they gave me the sense that Google was really the place to be, to do exciting new things. And so this was 2006. So Google was still the underdog, like everything with bright colors and colored balls, and everything is original and rebellious. And so I kind of I drank the Kool-Aid, and so I was really excited to join. I really wanted to join Google, but they rejected me. And so there was this user from Brazil that said, we have a free software conference in Brazil, in the south of Brazil. And I can get you, if you want, I can talk to the organizers, and we can have you come over and give a talk. And I said, sure, fine.
That's awesome.
And so typically, so this is a sort of typical for a Brazilian organization. I heard nothing for a long time, and so the date that I was supposed to fly was coming, and it was like it was coming like it was supposed to be on Sunday, and the Friday before the Sunday I hadn't heard anything. And it was I was kind of getting desperate, and so the Monday after this Sunday that I was supposed to fly, I was I was upset and disappointed. Yep. And so I went out drinking, and I came back and I decided to check my email. Yeah. And I'm very glad I did, because there was like this email saying, "Oh, we have your ticket is ready. You should pick it up at the counter at the airport."
Wow.
At 5 in the morning. And this was like 11 in the evening. And so I had to sort of grab my bag, call my parents that, I'm leaving. And so I went to visit Brazil. I went to visit this conference. And at the conference, there was this, the Google recruiters for the Brazil office were there.
Yeah.
And they had this deal: if you give us your resume, we will give you a t-shirt. And at the time, that sounded like an excellent deal. So I gave him my resume. I got the t-shirt. The recruiter, who's still there in Brazil, by the way, he looked at the resume and he thought, these guys in that did the previous run screens, they kind of dropped the ball. We should interview this guy again. And so I did a second round of interviews. They went very well. I got hired into the Brazil office. Getting there was also a kind of a difficult process, because you have to get a work permit. It's very bureaucratic. Probably doesn't have anything to do with developer tools, so I'll skip that bit. But yeah, so that's how I got into Brazil.
That's awesome. I guess there's an important lesson there, which is, as someone myself who's gotten rejected a lot, especially on the first try at various companies, I think there's a lot of value in persistence and trying again.
Yeah. At the same time, today I'm a manager at Google, and so I see these candidates from the other side. Yeah. And it's often really hard, because you hire someone to do in-depth work on a code base that's 10 years old. And, we do projects that take, weeks, months, quarters. Yeah. And, but we interview people and it takes 45 minutes. And so the question you ask someone has to fit in 45 minutes. And so it's very hard to get good signal on whether someone is a good fit for your team. And so I haven't solved this problem, even with my experience of being rejected at the first interview.
Yeah, I feel like it's one of those perennially difficult problems in the industry is figuring out a good interview process that's also time efficient for both parties involved. Yeah. Cool. So you joined Google, and what did you work on initially there?
So the Brazil office was a very small office. And at the time, there was this product called Orkut. I'm not sure if you're
social network,
old enough, you may remember it. It was the social network that was built by this Google engineer called Orkut Buyuktonen, I think it was his name. Yeah. And he decided to name the project after himself. It's not my first choice for a project name, but he sort of struck gold, and this thing became very popular. Yeah. And for some reason or another, Brazilians really like social media products. Yeah. And so they started flooding the product, and so it became kind of a quintessentially Brazilian and also Indian product for social media. So part of the engineering for the product was also transferred to Brazil. And there was a desire to make money. And so there was a group that was trying to figure out a way to serve ads on Orkut.
Got it.
And so I worked on that. And we also did ads on MySpace. Google had a deal with MySpace to put ads on their pages. And so that was kind of the same. We worked together with this group.
Fascinating.
And so maybe this is a good segue into developer tools, because this ad serving system, basically every web page that anyone viewed on the internet would have an ad, and most of those ads would come from Google. And so basically the system that we were working on, and when I say we, I don't mean just the Brazilian office, but there was like a larger group with probably maybe 1,000 people.
Yeah.
They were all working on this gigantic ad serving infrastructure. And so it had to be really efficient, really complicated. And so it was all written in C++. And, when products grow very quickly, you sort of run to keep up with the traffic and with the new features. And so it was a thing that grew quite, that had very rapid growth. Yep. And so this serving system that had to talk to many different backends, that was a thing that if you compile it, it would take... I don't remember the precise numbers, but I remember that at some point there was this unit test, and compiling the unit test took 1 minute. And then if you ran it, because it's a unit test, it's dynamically linked. So you think, well, dynamic linking is great, but it means that you do part of the linking actually at runtime. And so if you want to run the test, then the dynamic linker sort of tries to put these multi-gigabyte blobs together to create a binary. And so it took a long time. And so working on this system was actually quite frustrating, and it had a lot of pauses. It had a lot of places where you would press a button and then it would do something, and you'd basically have to do nothing for 5 minutes. And I found it very frustrating. And something else is that the Brazil office had very poor network connectivity. And we were using Perforce. And so if you've never used Perforce, if you want to edit a file in Perforce, the idea of
Perforce is a version control system, right? That predates Git. Centralized. Yeah. And they used to make promotion saying, well, Perforce is really fast because it does all the operations server side. Yeah. And that doesn't seem like a very scalable approach. And in particular, it means that if you want to edit a file, you can't just open the file and start typing. You have to tell the central server that now I'm going to edit this file. And so you have to update your metadata. Mm-hmm. And so you'd have to, do P for edit. That's the command. And then we were in Brazil, and the server was often overloaded, and that could take 1 second. It could take 10 seconds. And I found it extremely agonizing to use. And so, and I had just, for Lilypond, converted the Lilypond source code from CVS to Git. So I knew Git. I knew how to, the data model. I understood how to work with it. Yeah. And I thought to myself, well, I can do something better here. I'm going to build a wrapper around our Perforce installation. Mm-hmm. And then I can code against this local import into Git of the source code. And then once I'm done, then I press a button and it will make a Perforce change out of this local edit that I made. And then it can do this in the background, so I can do work on more interesting things. And I was a big fan of Python at the time. And it was another reason, because if you work in Python, you have like this direct feedback loop. So you change something in the source code, you press a button, and there's no compilation. Mm-hmm. You immediately get to see the result. And so for me, it was also a way to escape from this this morass of having to use to work with this gigantic C++ code base. Got it. So I built it for myself at first, and then I showed it to a couple of colleagues, and they said, "Hey, oh, that's nice." And before I knew it, there were like hundreds of users. And they would have all kinds of ideas on how to make it better. And so I would, improve it. Yeah. And they also, it turns out, so Perforce has this central server, which is not a great scalability idea. But if you do all the logic in the server, you actually have very firm control of the data. And so if you move this data to the client, then the server can be very lightweight or not exist at all. But then the data storage is in the client, and for version control, it's really important that data is not corrupted. And so there's, I discovered many ways in which to corrupt the data, and what, in all the ways in which this goes wrong. And so it was also an interesting lesson
into how to approach designing robust software.
Interesting. So this was essentially like a client-side like Git proxy to a Perforce server. So like as an end user, you'd only use like Git operations. It looked just like a Git repository.
Correct. Yes.
That's cool.
And so it became more popular. I think at the height of its popularity, it had like 5,000 users across the company. And so was I remember measuring the market share of my tool as the score of how well I was doing. And so my objective was for it to be 100%, but I think I never got past 25%. But at some point, 25% of engineering at Google used this Git wrapper around Perforce.
That's awesome. I would think that a lot of people would be inclined to use it because Perforce is kind of this. I think even this was back in
2009.
Okay,
10,
so
11.
It was like Git was not as widely adopted as it was then, but I feel like even then it had a certain cachet about it. Like people would have preferred to use Git over Perforce.
I remember being in my sort of nuclear introduction, and it was the time that Linus Torvalds came to give a talk at Google about his new version control system, and characteristically for Linus, he was a very adamant about the qualities of his version control system versus other version control systems, and he upset quite a lot if there were like people that really liked Perforce or maybe were the Perforce admins, and so they were quite upset having their system be described as crap.
What ended up happening with this kind of a Git proxy? I mean, 25% adoption is huge.
So what happened is that there's an interesting way to look at it. So I basically didn't want to use Perforce, and so I made a tool that sort of kept me away from Perforce. But if you build that tool, you actually have to programmatically talk to Perforce and understand precisely what operations should you issue, what do they mean, how can you make these operations faster. And while I was trying to not have to use Perforce, I actually, because I had written this tool, I had learned in quite a lot of detail how it actually works. And so that made me the perfect hire for the Piper team. And
got it. Piper is kind of describe Piper for those who might not be familiar with it.
Yeah. So if you want to know the details, there's a paper that Google published about it. But in short, it's a version control system that to the user looks quite like Perforce. But if you try to look under the hood, it's actually completely re-implemented from scratch. And it's re-implemented from scratch using Google infrastructure. And so it runs using a multi-data center deployment. So it has this distributed storage using Paxos that makes sure that if one data center is involved in a nuclear war or is on fire, then work just continues because there's 5 or 9 or I don't know how many there are, but there is a lot of data centers to make sure that if one data center goes out, then we can still continue work.
Got it. So it's essentially it exposes a Perforce interface to the user. So from the user's point of view and from Google's point of view, people didn't really have to switch from their Perforce habits, but underneath the hood, a lot of it basically completely different in order to scale to Google's like massive monorepo.
Right. And it's part of it is people's workflow habits, but I think very important is also automation because if you're and it's a lesson that I keep learning over and over again that migration is hard, and people you can teach people to do new things. But if there's automation talking to these systems, then you can only make a smooth switch if you have the old system and a new system respond exactly the same to an API.
Yep.
And otherwise, it's almost impossible to make a migration.
Makes sense. So I think that's an important lesson that every I won't say every, but like probably a lot of engineers discover over time. Migrations are super difficult. So the Piper team essentially hired. It sounds like their closest competitor, this kind of Git based, and that was the end of it.
You could see in that way. And so the Piper team was in Munich, and so I relocated to Munich. I'm still in Munich. If I look outside, I see the beautiful blue German sky.
Awesome.
And so I worked on the Piper team for a while, so the Git wrapper was a 20% project, a classical 20% project, and very. What is quite special is for you to create a 20% project and then leave it with another team.
Yeah.
But I managed to do that. So at some point, I decided to work on another developer tool. So I worked also on open sourcing our build system. Mm-hmm. And so when I switched teams, I left this Git wrapper with the Piper team.
Got it.
And they deleted it. So they built a replacement based on Mercurial, similar to Facebook, I think.
Yeah.
And so that is now the de facto way to do sort of distributed workflows.
Cool.
At Google.
So most Google engineers today see like a Mercurial like interface.
I'm not keeping track of how many people there are, but if you want to do, so one of the things that is hard with Perforce is that you have, let's say you want to implement a feature, but the feature needs a bug fix. Uh-huh. And so what you would do in Git is that first you make a commit that fixes the bug, and then you do a commit on top of that does the feature, and then maybe there's review, and if you use depending on what workflow you do, you can actually evolve both the bug fix and the feature independently. Mm-hmm. With Perforce, that's really difficult to do. You can kind of do it if you make sure that the bug fix and the feature don't touch the same files. Yeah. But if they touch the same files, then you're basically screwed. And so that is the workflow that my Git wrapper made possible, and that's also the workflow that this sort of the next generation of that, which is based on Mercurial, made possible.
Got it. I'm just curious because I noticed that in open source you've done some work on fuses what's the file system in userspace. Is that how you initially got into fuses? This work on Piper, or did that come later?
No, it actually came earlier. So what happened is that so I had this part of the reason why this Git wrapper was working was that Google had a file system, a virtual file system that gave you kind of all the files in the repository available locally. And of course, they're not really available because they're only once you actually go into the directory and try to read the file, then the file system would go and fetch the file. Yeah. And it was a read-only file system. But what is even more nice than having a read-only file system is having a read-writable view of the entire tree of the, 100 million files. Yeah. And being able to version control that with Git. And so I built this cute little hack that would use my wrapper sort of to explain this. I basically made a union file system of this read-only view and a read-write view where you could run the Git version control system. Yeah. And so that was what I wanted to build. And this was just around the time that Go came out. And so I thought it was a good opportunity to learn the Go programming language.
Got it.
And a Fuse file system sounded cool and interesting, and I didn't really know what they were. And so I thought maybe I should try to, write this Fuse file system thing in Go.
Yeah.
And so I ended up learning how file systems work and how to write Go all at the same time, using my Fuse library as a vehicle, which is probably not a good idea because this Fuse library is still around, and many of the early many of the early mistakes that I made 10 years ago are still there in the source code, and they're hard to repair because, as I alluded to earlier, backward compatibility is a great, fantastic thing to have. Yep. But if you want to fix fundamental problems, then often it means you have to throw out the backward compatibility. And so So I learned Go. I learned how file systems work. I made a pretty neat Fuse library for Go that you can check out if you're interested in that.
Yeah.
And it was all part of my greater plot to, I said 25% of people are using my tool at Google, and it was all part of this plot to push up this number from 25 to 30, 35. I'm sad to say that it was much less successful than my Git wrapper.
Yeah. That's awesome. I love the kind of entrepreneurial spirit that you had with dev tools inside Google. Tell us about joining the Bazel team, or was it the Blaze team?
Well, the Bazel team didn't exist as such because, but there was this idea that we could maybe open source the build system. Mm-hmm. And I was kind of involved with pitching that idea, and then I said, well, if I'm saying we should do this, I should put my money where my mouth is, and I should join that team. And
this was just for those who may not know what Bazel is or Blaze is. Blaze was Google's large distributed build system, internal, right? Or
almost. It's a build system, but it's actually not distributed. And also in Google, it's not just it's a single. It's written in Java, and it's actually a single process. And there's the actual compilation. Invoking the compiler is something that we do on a remote cluster. So that part is distributed. But Blaze is the part that figures out which files are out of date and what commands to run to compile new versions of that. And so it sort of builds the whole dependency graph of the project in memory, and then it checks which files were last modified, and then issues these commands. And
that's crucial for performance reasons, right? So you don't end up rebuilding the entire source tree, most of which is unchanged.
Yes. Well, it's both. The challenge is that you want it to be correct. And it's easy to be correct. It's just you delete everything and you build it from scratch again. But people also want it to be fast. And so you have to make this, often you have to make this trade-off between fast and correct. Mm-hmm. And so the slogan of Blaze or Bazel today is that it's both correct and fast.
Awesome.
So that's also a valuable lesson because up to then I was using the build system as a consumer, and as a consumer, if you're inside Google, it seems very polished. Everything is using the same infrastructure, and all of it kind of magically works. But then I actually joined the team, and I discovered so I had to learn Java. And it's really frustrating if you've had, 10, 15, 20 years of programming experience and you're in this new language and, you have the brain the size of a planet, but I don't know how to open a file. And that's really frustrating. And the other part is that as a consumer, it looked very slick and very polished, but like all software, it was built, you always try to be scrappy. You don't want to do more work than necessary. Yeah. And inevitably you end up with, especially if the project is older, you end up with source code with, it's underdocumented, or there's tests that are commented out, or there's basically technical debt. And so I joined the team, and I learned that the thing that looked shiny from the outside wasn't so shiny on the inside, and it was kind of my job to clean it up. And it was a lot of very, very hard work.
And I imagine it was, there's the tech debt part of it that you kind of want to get the house in a bit of good order before open sourcing. And I also suspect that a lot of it, like how much it was tied to, the unique way that Google does development. Because you're taking this Google internal tool and essentially trying to bring it into the open source. Was that like a big problem that you had to solve too? How to like generalize certain things and make it? So
I want to add the disclaimer that I was part of the people that proposed this, but I wasn't actually the technical expert. And so when I was joining the team, I was kind of the newbie, and the people that actually were thinking about these problems, I wasn't one of them, but I can try to answer your question anyway. So there is a part of infrastructure, like I talked about this remote build infrastructure, and that was Google specific and wasn't going to be part of the first version, and so that had to be cut out. And that was a lot of very hard work by one of my colleagues. But in a sense, it's straightforward because you kind of know where you want to go. Something that was much less straightforward is that inside Google, we check in all the dependencies. So we check in the compiler, we check in the JDK. If you run tar, like the archiving utility, we also check that in. And so we do that to get reproducible, to make sure that everything is reproducible.
Yep.
But when you download Bazel as a sort of external to Google, you don't first want to download a fresh copy of the compiler and a fresh copy of the JDK, because you'd start to use a program and you'd be downloading gigabytes of data. And so something had to be built to sort of import external dependencies, and that was an example of a problem that we didn't know in advance what exactly it should look like. And I think it went through a couple of iterations of refinement after I left the team as well. Got it.
So after the Bazel team, did you go on to join the Garrett team, or?
Yeah.
And when did you build Zoekt? Was that while you were on the Garrett team, or before?
Yeah. So untangling the build system from its Google internals was a lot of work. Yeah. And at some point I kind of burned out on it, and I decided, okay, I should do something different.
Yeah.
And so because I had been working on this Git tool, this Git wrapper, I knew the guy inside Google that was sort of the Git guy. So his name is Sean Pierce. He's one of he probably wrote like 1/3 of the upstream Git project, and then sort of made a version in Java of the same sort of JGit, basically. It's the Java version of Git. Yeah. And then he was hired into Google to provide the Android team with version control and code review. And so he had built this open source project called Garrett for doing code review on top of his library in Java that is doing Git, and ported that to run on the Google production stack, which is kind of complicated because in Google, everything is distributed. None of your computers have a file system because the files are all remote. And so he pulled that off, and he had been doing that for, I don't know, 6-7 years. And all the time that I was doing that, he had been sort of doing that one thing. And that really inspired me because he really seemed to very clearly know where he was going. And so I decided to work for him. And so his vision was to provide tooling, open source tooling, basically for everyone, but starting from the people that work on Android or that consume Android. Yeah. And one of the things he was hearing from people that used Garrett was that it didn't have code search. And so one of the things he asked me to do is, why don't you see if you can build some sort of code search thing? So I work in Munich, and the code search.
I guess real quick, just to set the stage for folks who are not as familiar with Google's internal dev environment, like code search at Google is a long time tool, right? It covers the vast majority of Google's code base, but Android is kind of this separate code base, right, from the rest of Google.
So there's what we talked about Piper before. It's we call that Google 3 because there used to be a Google 2. There was a Google 2, and then there was like this big reorganization that wasn't backward compatible, and it became Google 3.
Got it.
And that was a system that is sort of so scalable that it's become that is basically where all the code that runs on the production platform on the servers. That's in Piper, but there's a lot of other projects that need to interface with the external world. So there's Android has lots of partners, and so Android partners have to download the Android source code, and of course they can't use Piper for that because Piper is an internal product. Yeah. The Chrome web browser is something that people outside of Google also want to develop on, and so they need to download the source code, and they need to do a code review. And so they need external tools for that. And so they use Git. And to come back to code search, so there's code search for Google 3, which is, as said earlier, is sort of a standardized platform. And so you can do things like not just index the source code, but you can, because it's a standard platform, you can also run a compiler, and then the compiler tells you where the symbols are, and you can do cross-referencing.
Yeah.
Anyway, so Sean wanted to have code search for people that were using Garrett, and the code search team at the time was in Munich, and he said, well, why don't you go chat with these folks and see what you can come up with? And so I did. So one of the people that were involved, they kind of explained me how to build code search, what kind of algorithms you do. And then he also said to me, but there's a lot of work to re-implement from scratch. Maybe we should just open source our internal code search, which is written in C++, and it will be much faster than if you write it in Go, et cetera, et cetera. And so if you say to me, Han-Wen, this is way too difficult, you're not going to be able to do that. That is kind of waving the red flag to the bull. And so I thought, I'm going to prove you wrong. I'm going to prove that this is actually really, really easy. Awesome. And so I implemented the first version of this search thing. If you go back in the history of Zoekt, you can still find it. And it's actually fairly simple. So the basic idea is really very simple. And I got it to work. I don't know. It took me 1 or 2 weeks. Wow. And it's... But then you see it working, and it's really, and it's super fast. Yeah. And it's kind of an interesting problem, and it's kind of addicting to work on. And so I I immediately saw all these ways in which I could make it more fancy, faster, and so I've been working on it. It started really small, and then I thought, well, I should do regular expressions, and then I should do indexing Git repositories, and then maybe I should do multiple branches, and then and so every time, and I was doing it on the side, and it was a fun project. And so I was doing my sort of normal job, but in spare moments where my mind could wander off, I was always thinking about what is the next step of making my code search thing even more amazing.
Yeah.
So I got it to a point that it was really working quite well. I got my friends from the Bazel team to host me an instance. It's there's a cs.bazel.build. If you go there, there's an instance running Zoekt.
Yeah.
And I use that fairly regularly to search code.
Yeah.
But at some point, I thought, okay, it's I've proved my point now. I don't need to. I've proved this colleague of mine that said, well, it's a lot of work. And he was actually right. It is a lot of work, but it's also a lot of interesting work. And especially if you work at a company that makes most of its money by doing ads on search, it's actually quite interesting to know how search works. And so I felt that was useful. Useful background information.
Yeah, awesome. So aside from Bazel and your personal use, did anyone else at Google or like externally pick it up? Like, do you know of like who else is using it today?
So I occasionally get bug reports from people. And so then I conclude that they must be using it.
Yeah.
So I also, the Garrett community it has a couple of people, and there's this company, a Swedish company making security cameras that were also really anxious to get code search, and they told me they would name a street on their campus.
That's awesome.
In honor of me, if I would make it work for them. And I think they deployed it in the end, but I never checked if they really made the Nienhuysstraße, the Nienhuysgatan, or however you call street in Swedish.
Awesome. And I should mention also that Sourcegraph uses Zoekt as a backend. It's one of the it's probably the primary search backend for index search. So we have every Sourcegraph instance has a Zoekt instance inside of it, and we kind of call into the API, and it is, as you say, like super fast and incredibly performant to use. So nice work. It's quite impressive that you built all that in a matter of weeks. I mean, I'm sure it was a much longer maintenance and
So the first part is that you just search for strings very quickly, and that that takes a day or so. But then that's also interesting because you never stop to think about that. But then you have to not just build the data structures, but you have to put them on disk, and then you put them on disk, but then maybe you add features, and then the data on disk goes out of date, so you have to do versioning. And so all these problems that you don't stop to think about, they become actual problems that you need to solve. But it's been interesting, yeah.
Yeah, very cool.
And my compliments to the folks at Sourcegraph. So I heard first of Sourcegraph using this at one of the Git conferences where someone sort of got a binary from Sourcegraph and ran a disassembler on it, and then was surprised to see all these symbols. And he told me about this, and I was a little bit annoyed at first, but then you open source all of it, and now I'm really, really happy and really proud. And it feels good to be a part of a very successful business, even if I'm not really working for Sourcegraph.
Yeah, well, I mean, we are super appreciative for all the work you've done in this space. Zoekt is an amazing tool. It's so performant, and I think a big inspiration for Sourcegraph actually was Google's internal code search, at least for me, because I was a lowly intern at Google once upon a time, and one of the things that stuck with me from that experience was just being able to search over all the code that was kind of in that code base, potentially relevant to me from a single portal. And, we always just wanted to bring that sort of experience to every single developer, whatever code base they're working on, wherever they are in the world. So thank you for helping us get there.
Yeah, my pleasure.
Yeah. I guess, Google these days now has a public version of code search again. I mean, Google's always had seemingly like multiple instances or versions of code search. There's like the internal version, which has gone through various iterations. There was the public Google code search, which was around, I want to say like circa 2010 through maybe like 2014. And then it was sunsetted. And now there's code search available again. Are all these code search implementations like the same backend, or are they all just kind of like different tools and projects, inspired by the same rough concept, but distinct and different?
It's a good question. So the backend has gone through multiple iterations. The front end has gone through multiple iterations. There's also a bit of corporate priorities change, and so that has its impact on product gets turned up, gets turned down. So that's not really my. I'm not the right person to talk to these kinds of organizational decisions, but the infrastructure is has gone through several iterations. I think the people that work on it. I'm not sure if from the original team there are still many people there, but it's been so the original version was made by Russ Cox, I think, as an intern project. That's probably it's very rare for an intern to do a project that impressive. But if you're Jeff Dean's intern, then I guess that's part of the expectations. And I think that the code search for open source, the original one, which was launched maybe in 2009 or something, that became the internal code search. And it turned out that at some point the internal code search was more popular than the external one. I think that especially so nowadays everyone puts their source code on almost everyone puts their source code on GitHub, and then like there's this tiny sliver of people that put it on GitLab, and then there's these corporate weirdos like us that host their own infrastructures. So just having all the source code on GitHub gives you a central place to get all the source code to index, and you get signals about people put stars on it, so you know what is popular, and if you know what is popular, you can surface more relevant search results. And I think the first version of code search was sort of grabbing random tarballs off the internet, and so you got a lot of duplicate results. And so I think that was a limitation that kind of hampered its functionality, and that made it not be very popular.
Got it. And do you know, like, if because like Google now has code search available for its own open source as well as through GCP, is that kind of based on the same internal code search, or is that like entirely?
It's the same infrastructure.
Okay, got it. I guess another thing that you work on. Actually, before we get to Garrett, I want to go back to kind of the origins of Zoekt, because I think when we were talking earlier, you told this like really cool story that I think you were about to tell, but then I interrupted you about how you built it on a train, or like a train from. So like
So my wife was doing a PhD in a different city, and when I met my wife or then girlfriend, you meet each other and you go out in the weekend, and then during the week you work and you meet other people.
Yeah.
And then we went to Germany and we got married, and then she had to do this PhD in a different city. And when we started that, I thought, well, I've done this before. Like, we see each other in the weekends, and then during the week we do our own thing, and it's going to be fine. But somehow over these years, something changed, and so during the week I really, really miss her, and so I thought, I should visit her in this other city. And so it was. I live in Munich. She was in Erlangen, so this kind of a little bit far to do like a daily commute.
Yeah.
But if you go in the evening, take the train, and then the next morning you go back, take the train back to Munich, then it's fine. And so I had this every week on Tuesday evening. I would go to there, we'd have dinner together, and then the next day I'd take the train back to Munich. And so I had this, this sort of weekly commute, which took 1.5 hours. Well, you can't work on like Google internal stuff on the train because who knows who's behind you, but you can work on open source. And so I had, during the week, I would have all these ideas on how to improve my code search thing. And then sort of the idea of how to do it was kind of brewing in my head.
Yeah.
But then come Tuesday, I had the idea ready in my head and I only had to type it out. And then it was always, you try to finish it before the train reaches your destination. But if you look at the history of the commits, you can see that probably a lot of them were written either on Tuesday evenings or on Wednesday mornings.
That's incredible. In some ways, coding on a train, it seems like a maybe like tougher environment because you don't have your full desk set up, and you're on a moving vehicle. But there is something about it. I think you were touching upon this a bit that might actually be conducive to making quick forward progress. Like if you're thinking about this stuff in the back of your head, for the whole week, and you just like you're just like so eager to start coding on it, and then there's this kind of like time pressure element to it as well. Yeah. Do you think that contributed to the progress you were able to make early on in the project, or am I just kind of like completely wrong here?
I think the value of coding on a train, and actually planes work really well as well, is that there's just nothing else. Like there's no internet. Well, so there's internet, but it's very spotty. Usually there's all these other people that you're sitting close to each other, but then you pretend you're not looking at each other, right? You're sitting next to them, but you're not making conversation. And so there's this kind of isolation that's going on, and there's no way to distract yourself with there's no other thing to do. I think that is the value of coding on trains and planes.
Yeah. Hearing you describe that, it makes me think of the times that I've coded on planes and trains as well. And there is something different about that experience that almost might be worthwhile trying to like replicate. But I don't know how you would do it. Maybe it's just like something inherent to being in that environment with all these other people surrounding you that you're purposefully not talking to. And it's like moving somewhere, like the world's going by. I don't know.
Yeah, well, I've had very good luck with planes as well, and planes is in some ways so the train ride was only 1.5 hours, and you'd have to switch stations like halfway, and so I'd be on the train platform, and then you have to open and close your laptop all the time. So the plane is probably a better place.
Awesome. Well, we're coming up on the end of the hour here, but before I let you go, I wanted to hear a bit about your work on Garrett today, because that's what you're currently working on, right?
Yeah, so working is a big word because I'm what they call overhead. So I'm the manager of the team. The people that do the actual coding, they report to me, and I I try to be nice to them and help them wherever possible. But I'm, what should I say about Garrett? Credits to my team for making Garrett an awesome product.
I guess, one thing that might be of interest to the audience, because, these days, I think the vast majority of people are familiar with the GitHub pull request model of code review. And the Garrett model, Garrett predates GitHub and pull requests, and the model is quite different. And most of the folks that I talked to that have used Garrett before, and also GitHub PRs, much prefer the Garrett model of doing code review.
It's interesting that you should say that. I was looking at our internal survey of our code review tools, and the thing that there's a free-form text field, and we got a lot of feedback saying, "Oh, why isn't it like GitHub?" But typically, people that are happy with the tool, they're just going to write nothing, and when they have like a gripe, then they're gonna complain and take the effort to write something down.
Got it.
I agree. I think the model is better. So part of me thinks that the folks at dear folks at GitHub are my colleagues, and I should not disparage them. And
That's
part of me thinks that Garrett is really a better review experience. And so, how shall I phrase this without being disparaging?
Maybe talk about the key differences between the two models.
Okay. So the idea is that when you write code and you review it, it means that you're not actually producing the final version of the code. Like if you're producing the final version of the code always, then there's no need to review it, right? And the review is always there to sort of point out things that should be different.
Yep.
And so always when you write code, there's going to be a second iteration of sort of the same idea, but with a slightly different expression.
Yeah.
And so the idea of Garrett is that you perfect this expression of what you want to do, and then it's submitted. And that the result is that the history will have sort of the perfect version of the source code without your in between. There's people don't need to know afterwards that you made a typo in version 22 of this change.
Yeah.
And so you shouldn't expose that. And so Garrett is based on the idea that you make your commits, and if they're not perfect, you just tweak history so that it becomes perfect. And once it's perfect, then it's merged into the tree. Mm-hmm. And I think the misconception comes from a lot of people that use Git tend to say, well, you should never change your commits because then people can't merge, or you can't work together with other people. And so the moment you publish your source code for other people to consume, to pull in or to merge in, that's true. If you then change history, it will create a lot of confusion. Yeah. But if you don't do that, so the model that Garrett has is of a central authority, of a central server, which has the canonical place, and you want to polish that source code that you do submit until it's perfect, and then it goes into the central repository. Yeah. And one of the things that this enables you, because each commit, like I talked earlier about this case where you have a bug fix, and then on top of the bug fix, you do a feature. And so what you can do with Garrett is you can build these stacks of changes and have them out for review at the same time. And that is very hard in the pull request model because, why is it hard?
I mean, you can kind of like hack. I've seen people try to hack it with like having like multiple PRs that kind of merge into one another, or but sorry, I'm not describing this very well. It's just not automatic, right?
Yeah. And so the Garrett workflow kind of forces you into this mode where you polish your code until it's perfect, or until the reviewer is satisfied with it. And it lets you build like these huge stacks of changes and still manage the code review process well.
Yeah.
But the downside is in order for the tool to understand that version 1 of this, let's say it's a bug fix, version 1 of the bug fix is related to version 2 of the bug fix, it needs to connect those two commits. And so we do this by adding a footer to the commit message called change ID and then a big hex number. Mm-hmm. It only works if you add this random footer to the commit, and so that needs that confuses people, and also that sort of changing history, rebasing. Yeah. That is often something that people don't. That takes a little bit of extra. It's a skill that you need to learn how to sort of edit history.
Yeah. Do you have
if you don't have that skill, then it's more confusing.
Do you have any words of advice for folks who might be listening, who are interested in trying it out? Are there any good getting started guides or ways into the Garrett world?
Yeah, it's a good question. So we develop Garrett mainly for our internal customers, and if we were selling this as a service, we would make much more effort to have very polished get started documentation.
Yeah.
But we don't, and so there's I would have to look for that. There is a partner in the open source Garrett ecosystem called Garrett Forge, mm-hmm. and they run a version of Garrett that can easily import repositories from GitHub, and it can actually also you do the code reviews on their Garrett instance, and then once you submit, it gets pushed to GitHub. And this is actually how I do reviews for my Fuse library.
Cool.
So that's called Garrett Hub, I think.
Garrett Hub, yeah. I've heard of that. I was just talking to, do you know Paul Jolly at all? He's
no.
Anyways, he's creator of this thing called Q, which is configuration language, and he was tweeting about how they just moved.
Right. I thought it was I know. They used to be at Google, and there's this Dutch guy called Marcel van Lohuizen, I think.
Okay.
That was also involved in that.
Cool. Awesome.
But yeah, they moved to Garrett Hub.
Cool. Well, I think we're basically out of time. So just wanted to say thanks again for joining us today, Han-Wen. This has been a very enlightening and insightful conversation. Thanks for sharing, all your stories and experience with us.
Yeah. And thanks for having me.
The Sourcegraph Podcast is a production of Sourcegraph, the universal code search engine, which gives you fast and expressive search over the world of code you care about. Sourcegraph also provides code navigation abilities like jump to def and references in code review, and integrates seamlessly with your code host, whether you're working in open source or on a big, hairy enterprise codebase. To learn more, visit sourcegraph.com. See you next time.